So then you know that this is dorsal. So if this was a real, I don't know, a whale, I found a whale vertebrate on the beach once. So the vertebra would be around it, and the spinous process would be over here. The transverse processes would be over here. The body would be over here with the discs, and of course it's the disc you have to watch out for. They can press on it here. So the white matter is going to be cables. Now in this position, the cables are going to be going out like this. So you guys could be the brain, for example, with all of the neurons there, and the axons of those neurons are coming down in the white matter in tracts. And then every once in a while, one of them is going to be getting off at this level, and it's going to synapse with a lower motor neuron, and there's the axon of the lower motor neuron going out. So gray always means synapses. Somebody is talking to somebody else because you don't want insulation on your connection points. So big picture, white matter is going to be cables going someplace else, and occasionally some of the wires of that cable are going to get off to do something at this level. Gray matter is going to be synapses, connections. And then you're going to have more white matter because after you make your connection there, you're going to go off into the skeletal muscles, sensory neurons coming in the other direction. So that's kind of the way it goes. It's difficult because we're looking at a two-dimensional space on the blackboard. We can draw this segment and we can draw this segment, but it's interacting with things that are coming straight out of the board. So there's a little bit of that going on. That's why I have the other drawing that I put over here with the brain and the cord, sort of including that. So. Pyramidal tracts? That is, okay, so in really, when you're looking at the nervous system, you're looking like a lot of blobs that don't look like anything at all. And the neurologists are just desperate to name it after something. So if it looks ever so slightly like something, they'll name it after that. So the pyramidal tracts, the corticospinal tracts, the ones that you use for Wilbur. I'm going to pick this up. I just did it using my pyramidal tracts. If you look at them in cross-section, they look slightly like this. There you go, pyramidal tracts. They really don't look anything like that, but we also have, there's a part of the brain called the hippocampus, which is the seahorse, which looks nothing like a seahorse. There's the nucleus cuneatus, which is, the nucleus gracilis, which is graceful, and the nucleus cuneatus, which is like cuneiform figures in Babylonian script. No, it's just one of the features that actually does look something like it is the cortex itself. Cortex is Greek for bark, like the bark of a tree. Now remember, this would really be gray. And if you look at something that's gray and wrinkled, well, it does kind of look like the bark of a tree. So that's about it. Cortex actually kind of looks like what it is. But the rest of it, you'd need a lot of martinis to start seeing a seahorse in some of these structures. But, we do the same thing with constellations, right? Sagittarius certainly does not look like an archer. Duh.
Would you mind going back to that big model and saying what you said about dorsal root ganglion, the segment model? And you said how to orient yourself, and you said dorsal root ganglion, and you said cell bodies, unipolar.
If you're looking at a picture in a textbook or a text or even on the slides, some of them arrange like this and some of them arrange like this. It looks pretty much the same, right? But that's going to mess you up. So now I always draw it the same way so people don't go insane. I always draw the dorsal stuff on the top. That's just something that I do. But anyway, yeah, the dorsal root always has this. This is that bulge is only on one side. It's going to be on the dorsal side because that's the unipolar neurons of the first order neurons are there. Because remember, this is the dorsal root ganglion. And a ganglion is a cluster of nerve cell bodies in the peripheral nervous system. So that's ganglion.
So dorsal posterior sensory thing.
That's true.
Okay. And that means
That means something.
It's either descending or serious.
Well, it's going to be going into, that sensory information is going to feed into an ascending tract that's going into the brain.
Okay.
No, it's good. It's good.
And then this.
Is it, sorry, no,
For
is it
vertebral
always true? Go, you first.
Adult
Just if there, so you're saying there's no vertebral body there?
Well, I mean, the
It would be-
vertebral body would be here, I
Yes,
mean,
right,
right? So,
yes.
remember, this is the inside the vertebral canal, so yeah, if I hung a big, body would be there, spinous process there, transverse process there.
That's all.
Is it always true that the motor sensory is descending? As the sensory is ascending?
You said motor sensory.
Sorry, motor
is
descending.
Always.
Always.
Right, because the orders are coming from here and
Down.
going down to there, right. And sensory is always ascending for the same reason.
And motors goes dorsal.
No, motor goes ventral. Motor is in the front, anterior, ventral, like a car. Motor's in the front.
I don't use dorsal and ventral as much, so it's hard for me to.
Well, you do now.
Yeah.
So dorsal is posterior. Think of the dorsal fin on shark, dorsal fin. And ventral is anterior. I don't know how you remember that one, because it's not dorsal. So, ventral. The yin surfaces. So, just in time, everybody grab a piece of paper and choose a partner, do-si-do.